and we didn't have near the trouble that we had seemed to have on other subcontracted efforts on other programs. We also, on Peacekeeper, went to the first automated manufacturing cell and automated material system. This was done in conjunction with the Air Force on their Tech Mod program. Between the two of us, I think we invested around $17 million in this Tech Mod factory over in Building 270. But the dedication of the 1,600 people on Peacekeeper was something for a person to really behold. If there's any one thing that I think was the mark of success, that was it. The teamwork on the program, subs, suppliers, TRW, Northrop, just everybody, the customer. It was incredible. We didn't have any controversy to speak of. Oh yeah, you'd worry about little things day to day. But from an overall standpoint, never did we have controversy that interfered with the program. Subsequently, consequently, we made just about every schedule that a person could possibly dream of making.
On April 6, 1983, after nearly a decade of debate over the precise basing scheme for the Peacekeeper, President Reagan announced a plan to base 100 Peacekeeper ICBMs in modified Minuteman III silos at Francis E. Warren Air Force Base in Wyoming. However, in August 1985, Congress capped the number of Peacekeepers in silos at 50. Also in that same year, the Peacekeeper ICBM successfully flew its first test flight. The missile recorded a string of 18 consecutive successful R&D test flights and was hailed as the most successful development program of its type in U.S. Air Force history. The Peacekeeper program achieved a perfect flight test record and reached initial operational capability on December 22, 1986, when the first 10 Peacekeeper ICBMs became operational. This was 11 days prior to the program IOC date scheduled nearly a decade before. The entire complement of 50 Peacekeepers reached full operational capability on December 16, 1988.
At the present time, the Mecha itself is running at an MTBF about 100,000 hours, and the MGCS without the IMU in it is running at about 80,000 hours for MTBF. So the program was just a fantastic success. It doesn't matter which way you look at it.
In 1984, Rockwell was awarded a pre-production Air Force contract for integration of a guidance and control system for the next generation ICBM called the Small ICBM, a single warhead missile proposed as a highly survivable mobile weapon system. The goal of the Small ICBM program was to incorporate advanced technology to enhance the reliability and maintainability of the missile.
After Peacekeeper came Small Missile. We again had to compete. Wrote, I think, a very good proposal and won. Started down the path of a major development program only to have the country falter in its desires, and so we had that program terminated. Went on a few more years with Small Missile. Interest again turned around, and we got another very large development contract, in both cases about $500 million. And then shortly after we won that, they terminated it a second time. So I think while we performed very well on Small Missile, it's been a frustrating experience of getting everything up to steam and moving ahead with momentum, and then having the government terminate it.
In keeping with the original modernization goal of deploying a survivable mobile ICBM, the Reagan administration directed the creation of a rail-mobile Peacekeeper force. The rail garrison program called for redeploying 50 silo-based missiles to rail garrisons at existing Air Force bases. The trains would be maintained on strategic alert in secure areas on existing Air Force bases for day-to-day operations. The trains would leave their garrisons only in time of national need and be deployed onto the U.S. rail network. 50 Peacekeepers would be deployed aboard 25 specially built trains, with each train having 2 locomotives, 2 missile launch cars, a launch control car, a maintenance car, a fuel car, and 2 security cars. Rockwell's Autonetics Strategic Systems Division played a key role in the rail garrison program. In May 1988, the division was awarded a 5-year, $162 million contract to design, develop, and test the U.S. Air Force Peacekeeper Rail Garrison Launch Control System, which included the launch control car and the 2 security cars. However, while U.S. ICBM modernization continued, developments around the world would soon impact the work being done not only at Autonetics, but also at facilities of defense contractors throughout the country.
I personally think, and the people on the program think, we actually made a contribution to the nation's safety, the nation's defense, and our contribution to bringing down the Berlin Wall and the change in Russia as they attempted to compete with the technology and engineering that we were able to put into our systems.
In the late 1980s, the Soviet economy had reached the breaking point and simply could not withstand the price tag of their arms buildup, along with the burden of maintaining their worldwide empire. The result was a bankrupt Soviet economy and the dissolution of the Communist Party. START I, the superpower agreement, was signed in July 1991 by President George Bush and then Soviet leader Mikhail Gorbachev in Moscow. On January 3, 1993, President George Bush and new Russian leader Boris Yeltsin signed the second Strategic Arms Reduction Talks Treaty, START II, locking in cuts so deep that neither of the former Cold War foes could have an arsenal large enough to wage a surprise nuclear attack on the other. The long-standing threat of communism was gone, and the new age of peace was at hand. And everyone in the defense industry joined the world in celebrating this new era and took pride in their contributions toward this new peace. A bittersweet victory note rang out, however, when Congress re-evaluated the need for America's ICBM modernization programs. In its September 27, 1991 speech that would impact every defense and aerospace worker throughout America in some way, the Bush administration canceled several major defense programs. In response to the announcement and congressional approval, the U.S. Air Force announced on October 11, 1991, the termination of a contract with Rockwell's Autonetics division for the Peacekeeper Rail Garrison Launch Control System. In January 1992, the small ICBM contract was also canceled. But the true heritage of the ICBM fleet, the strategy of deterrence which had been spawned 40 years earlier, had been successful. Former President Ronald Reagan said it best when he reviewed the series of arms control agreements the U.S. and Soviet Union have signed over the years. In essence, he said they would have been impossible without the defense buildup. Specifically, he said, modern history suggested strongly that the men in the Kremlin respected strength and exploited weakness. A large part of the strength the Soviets respected was the Minuteman and Peacekeeper ICBM force. But the chapter in the history book of ICBMs is not yet closed. To help compensate for the dramatic reductions in the nation's ICBM force, the Department of Defense has designated the Minuteman III as the backbone of the U.S. ICBM fleet and announced plans for a Minuteman III guidance replacement program. In this role, Rockwell will continue to provide the technology and support which will strengthen our nation's security well into the next century. Hello again, and welcome back to the 1990s. As you've seen, the background of Rockwell's North American aviation and Autonetics organizations can best be described as a history of achievement. These achievements have contributed to the changes and technology advances that have brought America full circle, from the reality of the Cold War to the present era of superpower peace. Our work on all 3 generations of Minuteman and the Peacekeeper program set the pace for the research, development, and production of the most accurate inertial guidance and control systems in the free world. No higher tribute can be paid to the men and women of Rockwell than the knowledge that their fellow Americans can always depend on the unprecedented reliability of the Minuteman ICBM fleet, which continues to be the backbone of the nation's defense. These men and women are still very much proud of the past and poised for the future.
I'm John McLuckie, and today I'd like to introduce you to Rockwell's Defense Electronics organization. In this video, we'd like to give you a brief overview of our corporation, and more specifically, our defense electronics capabilities.
Defense Electronics is a market leader in its 6 market areas: avionics and aircraft modernization, tactical weapons, ship systems, command, control, and communications, guidance and navigation, sensors, Rockwell has built its global credentials in defense electronics over the last 40 years. For instance, Rockwell Collins avionics products have been sold in 57 countries worldwide for a wide variety of applications on fixed-wing and helicopter platforms, including communications, navigation, automatic flight control, and flight instrumentation. Major contract awards for aircraft modernization programs for the U.S. Air Force F-111F and the Royal Australian Air Force F-111C fleets have further strengthened Rockwell's credentials in this area. In fact, the F-111F flight test with the prototype aircraft have already demonstrated the successful incorporation of the state-of-the-art upgrade. Rockwell has made significant investments to expand its aircraft upgrade capabilities in specialized equipment and facilities, as well as in experienced personnel. A comprehensive avionics simulation and integration facility in Anaheim, California, is one of the company's most recent investments. The systems integration facility provides a state-of-the-art laboratory environment for rapid design, development, integration, and testing of avionics upgrade alternatives for a wide variety of aircraft and customers around the world. The facility's cockpit simulator provides a realistic 3-dimensional representation of an upgraded aircraft configuration. It has the capability to fly mission scenarios using a high-fidelity, out-of-the-window visual display.
One of the key features is to allow the pilot to maintain as much outside lookout as possible while still allowing him to make the necessary changes to his release modes. The next attack is using a CCIP mode on a bridge. Beginning the attack, selecting air to ground, CCIP, weapons are armed. Bomb release. Begin evasive maneuver.
The Rockwell Systems Integration Facility is an excellent tool to shorten the development cycle, and it also serves as a valuable crew training facility. The SIF is being used to address major avionics upgrade programs around the world for various platforms, including F-4, F-5, and P-3Cs. In ship systems, Rockwell has a long heritage of expertise in networking, systems integration, and acoustic signal processing. Our broad base of experience in multiplexing, signal processing, fiber optics, and ship design support has contributed to the development of the state-of-the-art networking system. For instance, our Data Multiplex System, or DMS, is in use today on the DDG-51 Arleigh Burke-class destroyers and LHD amphibious assault ships. The DMS is a modular information transfer system that dramatically reduces cable installation and adds flexibility and survivability while increasing monitoring and control capabilities. In addition, Rockwell is now upgrading the basic DMS to fiber optic technology, which offers a 4-fold increase in data handling capacity, increased immunity to electromagnetic interference, and significant savings in weight and power, all at reduced cost. Rockwell is also the prime contractor for the design and integration of the combat system for the Royal Australian Navy's new Collins-class submarine fleet. In this role, Rockwell leads a team of 28 subcontractors from 8 countries and 3 continents on this very exciting project. The Collins-class combat system is widely considered one of the world's most advanced. It features a fully integrated sonar, weapon control, and command and control system. It incorporates more than 40 Motorola 68040 microprocessors in a distributed architecture VME VSB system, utilizing a fiber optics data bus. The overall submarine is being built by the Australian Submarine Corporation in Australia, where the first of 6 submarines is progressing toward the start of harbor and sea acceptance trials, which begin in 1993. Rockwell's expertise in acoustic signal processing has led to the production of a variety of anti-submarine warfare systems for the U.S. Navy and international navies, such as Australia, France, Japan, the Netherlands, and the UK. We are also currently addressing similar requirements in other countries in Europe, the Far East, and the Middle East. They are also being used in numerous shore-based installations throughout the world to provide fast-time analysis of acoustic data in support of airborne and shipboard ASW missions. The remarkable accuracy of the United States ICBMs is directly attributed to the guidance and control systems produced by Rockwell. For over 30 years, we have designed and integrated guidance and control systems for all deployed U.S. Air Force ICBMs, including the Peacekeeper missile and all 3 generations of Minuteman missiles. In naval navigation, Rockwell is the leader in the production and support of the highest accuracy, longest endurance inertial navigation systems for the U.S. and U.K. ballistic missile submarines, attack submarines, and aircraft carriers. Rockwell also provides a variety of other navigation products, including our Global Positioning System receivers, which are found on every kind of military system from aircraft, ships, and cruise missiles to ground vehicles and personnel units. A strong sensors capability supports all of Rockwell's businesses. Our infrared focal plane arrays are used in such diverse applications as surveillance, thermal imagery systems, strategic defense, and tactical missile seekers. To meet varying sensor requirements, Rockwell also provides laser seekers for the Hellfire missile and millimeter wave radar seekers for the ERINT Theater Missile Defense Interceptor. The ERINT has been identified as a complement or replacement for the Patriot missile because of its superior hit-to-kill capability.
The combined capabilities of Rockwell's defense electronics businesses allows us to take an integrated yet flexible approach to the challenges facing military planners. We are dedicated to providing our customers with the best value products and services they deserve. To accomplish this goal, we plan to continue our outstanding execution on current contracts and to develop innovative solutions for future requirements.
In Anaheim, our Electro-Optical Center, or EOC, produces state-of-the-art infrared focal planes for systems ranging from space telescopes to ballistic missile defense, to tactical missiles and munitions, to forward-looking infrared sensors for aircraft. Products include military and commercial focal planes, radiometers, imagers, and sensor engines for infrared cameras. Production operations include ultra-clean semiconductor processing, from epitaxial growth to photolithography and etching, as well as focal plane and Dewar assembly, packaging, and automated room temperature cryogenic and reliability testing. The resulting products have seen the birth of stars at the outer reaches of the universe, warned defenses of Scud missile launches, provided night vision for drivers, aircraft and law enforcement, and opened low-price markets for commercial, industrial, and medical applications of infrared technology.